So another thing that you should have learned back in 120 that we're going to review a little bit right now is properties of matter. Now, we're going to look at things that you did cover in Chem 120 like physical and chemical properties, but then we're also going to learn something new called intensive and extensive properties. All right, so let's first look at our physical and chemical properties. All right, so our physical properties, these are things that we can evaluate without changing the composition of our material. When we observe a physical property and there's a change, those are physical changes. So I've got a couple of images here. Okay, so if I look at my hand holding the Erlenmeyer flask, the substance in the Erlenmeyer flask, what are some physical properties of that substance? Okay, well, if you thought of things like the color, it's green, the state of matter, it's a liquid. Those are physical properties. Maybe you thought, well, maybe it has an odor to it. That would be a physical property as well. All right, what about my other image of these drill bits? Okay, think what could be physical properties there? Okay, so things like, again, state of matter. These guys are a solid. They're shiny. They've got some luster to them. All right. Those are all things that are examples of physical properties. So this sort of a list should be very, very familiar to you. Color, conductivity, density, melting point, boiling point, hardness, solubility, etc. These are all going to be your physical properties. Okay. Now, when I think of, changes, all right, a physical change, I've got a couple examples of these here too. Like if you recall back in 120, you also got to do a little demo lab where your instructor should have taken some solid iodine, very gently heated it, and then it turned to a gas, and then up on the watch glass it got really cold and recondensed back to a solid. That's a physical change. Did I change the identity of my substance, my iodine? No, I just went from one physical state to another. Water, when I take water and I boil it, that's a physical change as well, because I'm just going from one state of matter to the other. Okay, we can also think of a review of our chemical properties. All right, so our chemical properties are going to describe reactions of one substance with another, and our chemical reactions are how those changes occur. Okay, so think about some chemical properties. What are some chemical properties that you can recall? So I've got a couple images here. If I take solid sodium metal and chlorine gas and I react them to make my sodium chloride, that's chemical. If I take my wood and I burn it, my resulting products, that's chemical. Okay. So a couple examples here too. Okay, rusting iron. So when I have pure iron, I just have iron atoms. When it rusts, it forms this iron oxide. So that's something chemicals happen there. If you've ever cooked sugar for like making candy or a glaze or something like that, caramelizing sugar. So if you think about it, a lot of these are irreversible. Not necessarily not every chemical change is irreversible, but a lot of them are. And so, these were definitely forming something new. Okay. So here is a couple of sentences. Okay, I want you to read through this and I want you to figure out which ones are physical and which ones are chemical. So pause the video, take a look, and see if you can identify the physical first and then the chemical second. Okay, let's see how you did. So our physical, all right, I've got the sample of calcium. It's electrically conducting. Oh, that's a physical property. Okay, so I'm going to put green on our physical properties. White metal, white, that's physical. Metal, okay, shiny, soft. Oh, the melting point, so melts at 850, boils at, okay. Those are all examples of physical properties. Okay, so now let's see chemical. We place this into some water. Oh, there's some more physical properties. We've got liquid water that was at a temperature. Ooh, Okay, so we had some physical properties of our water too. Now let's see here. Can we identify any chemical properties? Calcium reacted slowly with the water, to give bubbles. That's some evidence that something chemical has happened. So the formation of the bubbles of gaseous hydrogen. Well, we didn't have any hydrogen before, so that's something new that formed. And a solution of calcium hydroxide. Okay, so in green, okay, I had the physical, and in blue, I had the chemical. Right? So we've got all sorts of different processes there, our chemical and our physical. So again, those physical properties, we're going to be able to describe those without having to do any changes. Chemical, now things are changing. Okay? Now, one thing you may not have learned in 120 is about our intensive and extensive properties. So intensive properties, these do not matter how much of something I have present. So I can have a teeny tiny little piece of something or a big giant sample of something, and my intensive properties are always going to be the same. So if I have a substance that is green, it will be green no matter how much of it I have. Now, the intensity of that green, that may change depending on how much I have. If I have a ton of it, maybe it's a more intense green, especially if it's a solution. But if I have a sample of the same substance, it's always going to be green. Odor, okay? Luster, the melting and boiling point. So if I have water, it doesn't matter if I have 100 mils of water or 1,000 mils of water. That water is still going to boil at 100 degrees Celsius. It's still going to freeze at 0 degrees Celsius. Now, it may take longer for the process to occur with the larger sample of water. Okay, so the time it takes for something to happen may change, but the temperature at which it happens, that does not change. Okay, the specific heat capacity. All right, this is the amount of heat required to change 1 gram of a substance by 1 degree. That doesn't change the amount that I have. How malleable it is, how ductile it is, so if I can, spin it into wires, spread it out. How conductive it is, how dense it is. So again, if I have a tiny piece or a big piece, remember, density, most common units, grams per mil, so it's mass per unit volume. So if I have a bigger sample, I'm going to have a bigger mass and a bigger volume, but the ratio of the mass to the volume should still be the same, which is the density, the pressure of something, okay? So this does not depend on the amount of our sample. Whereas extensive properties, they do depend. So if I look at things like mass or volume, that is going to depend on the amount of sample I have. So here I have some sulfur. Well, the sulfur is yellow regardless of how much I have. The melting point doesn't change regardless of how much I have, all right? But the mass, that changes. If I have a big sample, I have a bigger mass. If I have a little sample, I have a littler mass, okay? So let's say that you have an unknown substance. You've got a sample of something. Like, let's say I go to my periodic table element dice things and I grab another one. And instead of showing you the identity this time, here's another one. Okay? What types of properties are going to be more useful for you to try to determine what the identity of this particular dice is? Okay, is the mass going to help you determine the identity of that dice? But let's say you have the mass and the volume. If you have the mass and the volume, you can determine the density. Okay, and is density an extensive or an intensive property? Density is intensive. Okay, so intensive properties are more useful for identifying an unknown substance because regardless of your sample, every sample of that substance is going to display the same intensive properties. I'm always going to have the same density. Okay, so intensive properties. We're always going to have the same melting point, always going to have the same boiling point. Those are going to be the ones that are going to help you determine the identity of an unknown substance.